There is a place deep in the ocean where pressure is 1,000 times stronger than that we're used to at the surface. This force is enough to turn an unprotected human into dust instantly. Well, maybe more like mud. Anyway, that's why explorers need some serious preparation and equipment to survive in such extreme conditions down in the Mariana Trench. It is as wide as 20 national malls in Washington, D.C., and about 1/5 as long as the diameter of Earth. People who went all the way down describe it as a chilly, quiet, and very peaceful place. They saw a bright blanket of red and yellow rocky outcrops, and there was a whole variety of unique, small, translucent animals. The popular myth is that more people have gone to the moon than to this deepest place on Earth is not true, though. In total, 24 humans flew to the moon, and at least 27 brave souls dove down to the Mariana Trench. Most of them were explorers and not proper scientists. They just go there for the thrills and also to collect video evidence of different wildlife, geological formations, and human-made objects. Humans started traveling around space and into the ocean depths at around the same time. The first moon landing was in 1969. And the first person to go down the Challenger Deep, the deepest part of the Mariana Trench, did so in 1960. This unusual location got its name after the British ship HMS Challenger, which first located this massive drop in the ocean floor at the end of the 19th century. It would take 8 more decades before the first human went down to it. Explorers didn't manage to do it in a conventional submarine. They used a type of submersible called a bathyscaphe. The Swiss oceanographer Auguste Piccard designed his own in 1953. 7 years later, the submersible managed to do the impossible. It had reached a depth of nearly 36,000 feet. But what explorers saw was merely a fraction of the trench's full size. The fact that it is so huge of the Mariana Trench is just one of the reasons why it's mostly unexplored today. The absence of light is another major issue. Sunlight is incapable of reaching such profound depths, so the entire trench from top to bottom lies in absolute darkness. Because of such conditions, the ecosystem is a lot different than the shallower regions of the Pacific. This puts immense pressure on marine wildlife. Yeah, the pun is intended. Another reason why it's so challenging to survive there is the temperature. Water freezes at 32 degrees Fahrenheit. At the bottom of the Mariana Trench, the ocean is just a couple of degrees above freezing. One of the factors that hasn't let this area turn into a giant icicle is the fact that salt water has a slightly lower freezing point. The other reason is geothermal energy that warms the ground at the bottom of these just enough for it not to freeze. That's why submersibles need to have proper insulation to navigate these icy conditions. When they reach the bottom, researchers find out that this desolate and harsh climate is home to several animal species. They encountered arrow-toothed eels, snailfish, and spoonworms at various depths. There were even strange-looking translucent sea cucumbers and shrimp-like amphipods. The biggest surprise was microbial mats thriving on methane and hydrogen from the mud. Among the species, the Mariana snailfish looks like a master of the environment that can go farther and deeper into the trench to feed on prey than its competitors. Despite its seemingly fragile appearance, the snailfish has adapted to withstand extreme pressures, a superpower it wouldn't be able to survive without. The exotic life forms that live deep down aren't normal-sized, since deep-sea gigantism makes them grow significantly larger than their counterparts in other ecosystems. One example is the giant tube worm, which can be 6 feet long. Science has a hard time explaining the exact cause of this form of gigantism. Thermal vents are just one of the possible explanations. All of these factors might help explain the huge time gap in researching the Mariana Trench. The first successful dive after the 1960 expedition came only in 2012. That's when the famous Canadian film director James Cameron went down in the deep-sea Challenger. Because few scientists have gone that deep before or after Cameron, There is no map of the deepest point on our planet. We know very little about the oceans that cover 2/3 of the Earth's surface. Researchers have mapped out only 5% of them so far. Science still has a lot to discover in the Mariana Trench and other unexplored places on our planet. The Amazon rainforest stands as the best example of the world's most unexplored regions. The list of reasons why this part of South America is unknown starts with its wildlife: jaguars, anacondas, piranhas, black caimans, and Brazilian wandering spiders are just some of the creatures that pose a risk for researchers. Relentless year-round rainfall induces heavy flooding. Add to all this some treacherous river currents, and you can see why scientists have mapped such a small percentage of the Amazon to date. In just one region of Brazil, near Peru, there are at least 14 tribes that have never had contact with the outside world. The national authorities intend to keep it that way. Isolation of these indigenous people is the best way to protect their future. The same goes for a remote island in the Indian Ocean. After the tragic tsunami of 2004, helicopters flew over North Sentinel Island to make sure its inhabitants were alive and well. Meanwhile, the Sentinelese weren't thrilled. They took up bows and arrows to drive away the unwanted visitors. This tribe is one of the last uncontacted tribes on Earth. Although anthropologists and filmmakers visited the island in the late 1960s, we still don't know much about its indigenous population. It sits a long way off any shipping lanes in the Bay of Bengal. North Sentinel has no natural harbor, and it's surrounded by a shallow reef. This makes access to the island possible only by boat. The Indian officials who lay claim to the island have prohibited outsiders from visiting the island for safety reasons. The estimates on how many people inhabit the island vary significantly, from as few as 15 to as many as 500. The island is not tiny. It's about 5 times as big as London's Heathrow Airport. Apart from occasional contact during the past 2 centuries, the Sentinelese must have been isolated for a long time. They are related to other indigenous groups in the Andaman Islands, but their neighbors cannot understand a word of their language. The continent of Antarctica has no permanent human settlements at all. The only people who periodically live there are international scientists. This vast expanse of ice and snow, roughly the size of the United States and Mexico combined, still has many regions where humans haven't set foot. Satellite imagery and photos that NASA's aircraft made from the air have mapped out the entire continent. So we know where to go, but it's not that easy. The reason for this are all the adjectives that go with Antarctica. It is the coldest, windiest, driest, and brightest of the 7 continents. This makes it virtually unlivable. More than 99% of its surface is covered with a permanent sheet of ice. Its thickness ranges from 1 mile to as many as 3 miles in some places. That's half the height of Mount Everest. Now, the Himalayan range contains the world's tallest unclimbed mountain. It is also the tallest mountain in Bhutan. In the local language, the mountain's name translates as White Peak of the 3 spiritual brothers. Out of respect for the spiritual beliefs of the local population, national authorities restricted and then completely banned mountaineering at the beginning of the 21st century. To this day, there is no evidence that any climber has ever managed to successfully reach the summit of this mysterious mountain.
Ever wonder why, despite all our advancements in technology and science, there's a vast expanse of our own planet that we barely know about? Believe it or not, over 80% of our oceans remain uncharted territory. It's as if we've got this massive aquatic playground in our backyard, and we've barely scratched the surface. Also, did you know that only about 7% of our oceans have a special tag called Marine Protected Areas, or MPAs? How come this colossal body of water that envelops most of our planet is also among the most vulnerable and misunderstood spaces in the universe? Pressure has a lot to do with it. Our deep ocean is a beast of a place with no visibility, freezing temperatures, and pressure that's so intense that in certain areas it would make you feel like you're having the weight of 50 jumbo jets on your body. No wonder we're having an easier time sending people into space than to the bottom of the ocean. The deeper you go into the waters, the more pressure piles up. But let's not forget we have tech on our side, right? Scientists now use these cool satellite technologies that track the color of the ocean to check how much phytoplankton is there, for example. Why is this important, you might ask? Because these little plant-like critters are actually pretty major players in our big blue oceans. In the grand scheme of things in the aquatic world, phytoplankton is like the bedrock of the ocean food chain. It gives life to almost everything, from the tiny zooplankton, which are animal-like microorganisms, to those colossal, magnificent whales. When these technologies first came around, satellites could get clear images of the ocean faster than a ship could take the same number of measurements in 10 years. But it's not all about looking at the ocean from space. Sometimes you gotta dive in there and see it for yourself. Thankfully, we've come a long way in ocean exploration tech too. We've got things like floats and drifters that ride the ocean currents while collecting data, and a whole fleet of underwater vehicles, some of which are manned, some remote-controlled, and some even autonomous. Remember James Cameron, the guy who made the movie Titanic? He's super into exploring the ocean, and in 2012, he set a record by going down to the Mariana Trench in a vertical torpedo sub. He thinks there's nothing like being in the ocean and experiencing it firsthand. Other companies use a mix of technologies for their ocean explorations. It led them to discover amazing stuff like a deep-sea coral reef near Morocco, the only one still growing in the Mediterranean Sea. They've also discovered new species and documented ones previously thought to live only in the Atlantic. These efforts have convinced local authorities to declare some places as marine parks. As with most scientific areas, the road isn't without its bumps. These expeditions can cost quite a lot, and the lack of detailed maps and data only adds to the challenge. We can't always rely on bathymetric information, meaning the study of the ocean floor, because it's often not available. And that's the tricky part. We need to explore more to know more. But getting the funds for these kinds of projects can be tough when there are so many unknown variables. One particular company's explorations have helped protect nearly 4 million square miles of ocean so far. The data they collect during their expeditions is invaluable. It's used to identify new species, locate vulnerable habitats, and even show where threatened species are being overlooked. Their work helps dismiss excuses from local authorities who claim they lack the necessary information to establish more MPAs. The same company supports a goal known as 30 by 30, aiming to protect 30% of our oceans by 2030. It's a big target, and there's a long road ahead, but ongoing ocean exploration can provide the proof needed to keep more of our oceans safe. We also need to set aside areas for protection and research, even when we don't have all the facts just yet. On that note, some cool scientists have recently stumbled upon a gigantic and mysterious world beneath the Pacific Northwest coast's ocean floor. The best part is, this massive realm of life is pretty much cut off from the rest of the world above, making it like a secret underground club that only the best microbiologists have access to. Picture an active city. Except the city is microscopic cracks in the basalt rocks of our oceanic crust, and its residents are microbes. These tiny creatures aren't like you and me. They don't rely on sunlight or the organic products of land and water ecosystems for sustenance. Instead, they thrive on chemical reactions with rocks and seawater. Scientists call this type of life chemosynthetic, which sounds complicated, but it basically means life sustained by chemical reactions. While this sort of life has been found deep in mines and around seafloor hydrothermal vents, the scale at which these creatures are found under the oceanic crust is unprecedented. It might even be the most extensive ecosystem on Earth. A geomicrobiologist from Denmark was part of the team that made this discovery. He claimed that over 50% of our planet's surface is oceanic crust, which is an average of 4 miles thick. Imagine the size of this chemosynthetic party happening down there. This discovery didn't happen overnight. Since the 90s, scientists have found weird tiny holes in the basalt rocks that make up much of Earth's outer crust. They seem like they might have been made by bacteria, but hey, there was supposed to be no life there. I mean, imagine trying to survive in a place that's hot, deep, dark, dense, and mostly devoid of the organic compounds we need for life. Yet, here they are. In the following years, more pieces of the puzzle fell into place. Scientists found that the oceanic crusts had different conditions at the centers and edges. At the centers, rocks are jam-packed with energy-rich compounds that support these tiny life forms. But by the time they reach the edges, these chemicals are all gone. Fast forward to now, and it's time to put the puzzle together. A microbial ecologist from the University of North Carolina worked on this research and says we now have solid evidence of microbial life in the cracks and crevices of deep ocean basalt. The next question scientists asked was, how far does this life extend? Researchers collected samples of crust from a plate roughly 120 miles off of Washington's coast, drilling deep beneath the ocean's surface. What they found down there was remarkable. The life down there runs on a unique fuel, hydrogen. Yep, in the absence of sunlight, hydrogen provides the energy for all their biological processes. These microbes use hydrogen to transform carbon dioxide into organic matter. This matter and other byproducts, like methane, then fuel other organisms, creating a network of life. Of course, the life down there isn't as complex as the one we know up here. Scientists doubt there will be any multicellular life under the ocean because it's too hot and energy poor. But hey, who knows? This universe under our oceans still has a lot to reveal. This whole thing is significant for many reasons. First, it confirms that life can exist in places without oxygen, which changes our perspective on where we can find life. This makes us wonder if life could exist under similar conditions on other planets, where surface conditions might be too harsh. The implications on Earth are also profound. If a large portion of life exists in the oceanic crust, then our understanding of life on our own planet could be completely changed. This exciting discovery stretches our understanding of life and prompts us to keep exploring the mysterious depths of our oceans, pushing the limits of our understanding. NASA is also in on the whole deep sea exploration project. Why? Shouldn't they be preoccupied with outer space? Because they're hoping to find hints about what the oceans on other planets might look like. NASA specialists are really hopeful that by unearthing underwater secrets, we can solve some of the big questions about space. Plus, they're testing some nifty equipment for future journeys across our solar system.
If you could dive right into the mysterious darkness of the ocean depths, who knows what you'd come upon? Legends that are hundreds of years old mention some giant sea monsters hiding deep down below the ocean waves, like the Kraken, the Loch Ness Monster, the Hydra, Leviathan, and so many more. Okay, no one has ever seen such monsters, but there are still weird and unusually big sea spiders, squid, worms, and many other animals that grew way more than we'd expected. Take a look at the colossal squid from sub-Antarctic waters. It's around 14 times longer than the arrow squid that lives near New Zealand. And deep down in the Pacific Ocean, there's a sea sponge as big as a minivan. Oceans contain about 96.5% of all water on our planet. Up to 80% of all life on Earth we've discovered is under the oceanic waves. We haven't explored, mapped, or even seen more than 80% of the ocean. In fact, we've mapped Mars better than we have the ocean bottom. The pressure down there is insane, and it would make you feel like you're holding up almost 50 jumbo jets. And temperatures at such depths are extremely low. Conditions deep below the oceanic surface are harsh, so creatures that live there need to adjust. That's why many of them grew very, very big to survive. Creatures that live in cold, dark depths are so big because of a phenomenon called deep sea gigantism. The deeper you go below the oceanic surface, the less sunlight there is. That's why the temperatures drastically fall. The result of this is increased cell size and longer life of creatures. Also, these creatures don't have as much oxygen as the marine animals that live in shallower parts, and their food sources are minimal. Much of the food they get comes from shallower waters, and only a little bit trickles down to the deeper parts. And when there's not enough food, being large is an advantage. Larger creatures can move farther and faster to find something to eat. Their metabolism works slower. They don't digest the food that fast, so they can store food and conserve energy for hard times when they can't find anything to eat. They don't need to regulate their body temperature either, which also helps them save some energy, which they can then transfer to other body processes. They mature more slowly and later than those living in shallow waters. The majority of fish species that dwell in deep waters live 30 years or even more. Orange roughy fish, on the other hand, live up to 150 years. This fella grows 24 feet in length and weighs up to 1.5 tons. But it grows to be so big for centuries. They start looking for partners when they're 150 years old, and they can also live this long because there are not so many predators at such depths. Also, there are no humans or other things that can disturb them or endanger their existence. At such depths, the environment is pretty stable, so many animals there are like living fossils because they probably haven't changed in millions of years. The first 650 feet of the ocean's depth are considered to be the open ocean. The majority of the marine life we've discovered lives there, since that's the area the sun can still reach. And then, as you continue going deeper, you reach the twilight zone. It seems like nothing lives there. But at about 820 feet, you see a small oasis of ancient life blooming. For example, there are sea lilies, animals that have been living at such depths unchanged for millions of years. Coelacanths, another living fossil, have been living in the ocean for more than 360 million years. Hagfish haven't changed in a very long time either, for over 300 million years. This creature lives at depths of 5,500 feet. They evolved before the rest of the vertebrates, which is why this is the only living animal without jaws or a spine, even though it still has a skull. Deep-sea creatures can't survive in shallow waters. They've evolved to live in depths under bigger hydrostatic pressure. Humans and other organisms that have internal spaces filled with gas would end up crushed if we could go to such depths. That's why deep-sea divers always need to wear special dive suits designed for surroundings with higher pressure, even though they're not going that deep to the areas where these giants live. But near Antarctica, you can see gigantism way closer to the surface, like giant sponges, sea slugs, sea spiders the size of a dinner plate, worms, and even some enormous single-celled organisms. They all tend to chill in shallower waters. Scientists are not sure why exactly, but they think it could have something to do with oxygen. Giant species use just a little oxygen, and the waters around Antarctica are pretty rich in it, which means there's hardly any limit to these animals growing bigger and bigger. Back to deep-sea creatures. As mentioned, they had to adjust to strong pressure, so they almost don't have any air gaps in their body at all. They're mostly water-based, and since water is incompressible, which means it's not something you can compress, it helps them stay unaffected at such high pressure. But because of all that, if they were to go up towards the surface, they'd probably swell up, maybe even explode. Just look at the blobfish, the one that takes the title of the ugliest animal in the world. It looks normal deep down below the surface, where its natural habitat is. But when it gets up to the surface, where the pressure is 120 times lower, it changes its shape. The blobfish doesn't have a skeleton or muscles, so without high deep-sea pressure, it ends up being all floppy and saggy. The dark oceanic depths are not just scary to watch, but to listen to as well. In 1997, scientists were trying to find underwater volcanoes located off the South American coast. During their travels, they recorded one of the loudest noises ever registered. It was pretty weird, too. It was so loud, even sensors from more than 3,000 miles away managed to pick it up. They later called it the bloop. It took them 15 years to conclude the sound came from an ice quake. That's when seismic activity breaks frozen ground. Water at the bottom of the ocean is not always extremely cold. There are hydrothermal vents on the seafloor, and the water that comes out of them can be up to 750 degrees Fahrenheit. Powerful pressure, yep, the same one that would crush you, is something that doesn't allow the water to boil. There are hundreds of animal species that live near deep-sea hydrothermal vents. Some of them, such as tube worms, are not like anything we have seen before. These worms absorb chemicals from vent fluids. That's how they feed bacteria that live in them. And in return, those bacteria give them the carbon the tube worms need to survive. 2/3 of all of the coral species scientists discovered live in dark, deep, and extremely cold parts of the ocean. Some even live in parts that are 3 miles deep. They can survive at low temperatures, such as 28 degrees Fahrenheit. Some of these cold water corals are more than 8,000 years old. They form amazing structures that can rise up to 115 feet tall. The deep is not just a mysterious world of unusual creatures. The landscape under the oceanic surface is magnificent too. The canyons hiding there make even the Grand Canyon seem small. For instance, check out the one located in the Bering Sea, the Jemchug Canyon. Its vertical relief is more than 8,500 feet deep. That's huge. The largest ocean waves are not the ones you can see from the shoreline. They occur under the surface, and they're called internal waves. They take place between two water masses that have different densities. They travel at speeds of thousands of miles per hour and can be 650 feet tall.
So, Megalodon was one of the biggest and most ferocious monsters on our planet. Powerful jaws, razor-sharp teeth, gigantic size. But what do you know about how it sounded? Imagine how loudly it growled, permeating the underwater world with sound vibrations. This sound resembled nothing. Megalodon didn't have a voice. It was a shark, and sharks don't have sound-producing organs. It was a quiet danger. But despite its muteness, yes, that is a word, you could have still heard it. Come with me. Now you're underwater, clenching your fist, raising your hand, and quickly bringing it down. Now imagine that you have a big submarine instead of a fist and hear the water flowing around the smooth surface of the hull. That's what a megalodon sounded like. When this monster was swimming out to the surface and opening its jaws, it sounded like a waterfall. The giant shark swam at high speed. When the water was passing through its mouth and gills, it sounded like a flowing river, a fast, powerful river. Megalodon had no voice, only the scary sound of flowing water. Other ancient fish could make sounds, but you would hardly hear them. Whales, dolphins, and their distant ancestors are not counted because they're mammals. Fish communicated at frequencies elusive to human ears. They still have this ability, but in most, the ocean was and is a pretty quiet place. So let's get out on ancient lands and check what was going on with the sounds there. Thanks to modern technologies, scientists can analyze the sounds of many ancient animals. Using CT scans, they found that some dinosaurs had complex systems of small open pockets in their skulls. They used these winding cranial mazes to reproduce a wide range of sounds and regulate body temperature, and people have managed to hear them. An ancient bird that lived 79 to 140 million years ago, Pegasus, sounded similar to some farm birds like duck and geese. But the ancient creature probably screamed in a scarier way. Scientists found this out thanks to the Syrinx fossil they discovered in 2016 in Antarctica. It's the oldest known vocal organ in the world. It helped Pegasus make a double humming sound coming from the left and right sides of the Syrinx. Imagine a duck and goose screaming. Increase the volume several times. Perhaps that's what its distant ancestors sound like. As for other flying reptiles like the pterodactyl, it couldn't scream like Vegas's because it didn't have a syrinx. These winged monsters could growl, hiss, and snap their beaks, and this was their most effective sound. Remember any tall basketball player. The skull of the pterodactyl was slightly longer than their height. Just imagine what a noise the dinosaur created when it was snapping its powerful beak. The clicking sound could deafen and frighten other ancient creatures nearby. Now, you probably know what a Tyrannosaurus sounds like, thanks to the movies. Among thousands of others, you'll recognize this prolonged roar similar to a chainsaw, vacuum cleaner, and horn. And, honestly, its roar has a lot in common with the natural sounds that this monster could make. Thanks to modern technologies and well-preserved remains, scientists managed to simulate the voice of these ancient animals. Imagine you're uploading data about a T-Rex into a program and preparing to hear an intimidating roar. You press play, and it sounds like a bee. Tyrannosaurus rex's scream was similar to birds, not mammals. But it wasn't just a beep. It used nostrils to scream, not a mouth. The hum came from the chest and resembled a siren with low bass. Maybe it sounded a lot more intimidating than what we saw in the movies. It was louder than all the trumpets of the symphony orchestra, and it did it only with the help of its nose. It's not known for sure whether it could growl through the mouth. You could also hear how long-necked dinosaurs sounded in the movies. Their calls were similar to those of elephants, something between a saxophone and a car horn. But in fact, these tall creatures whispered. Almost all mammals make sounds thanks to the laryngeal nerve. This nerve runs down along the neck, then goes around the blood vessels of the chest and comes back to the larynx. In short, the brain gives a signal and it passes twice the distance along the body before the sound is released from the mouth. And now, remember those long necks of dinosaurs? This was the height of a 5-story building. But the voice signal had to run a distance of 10 floors. It took too long to make this long trip, and this affected the dinosaurs' roar. So, when they wanted to make a sound, they just hissed. And it was probably similar to the sound of a giant viper. But the most detailed sounds scientists have managed to get belongs to the Parasaurolophus. You know this herbivorous dinosaur thanks to the long crest on the back of its head. We saw the dinosaur using it in movies and documentaries to fight opponents and enemies. Some scientists believed it also used the comb to drop fruits and leaves from trees. Others thought the dinosaur used it to improve its sense of smell. But it turned out that in addition to self-defense and fighting, they used the comb to make loud and scary sounds in different keys. Scientists replicated this with fantastic accuracy, thanks to the structure of its hard tissues. Almost all living beings with a voice use soft organs to make sounds, and these soft tissues decompose quickly. Parasaurolophus had solid ones. They noticed tubes leading from the nostrils to the crest and back to the nostrils when they found the skull. It was like a crumhorn, a curved musical wind instrument. This proved the dinosaur used the crest on the back of its head to make the sounds louder. The comb allowed it to trumpet, so its relatives could hear it in the forest. They made humming sounds with low and high notes. Mix a saxophone and trumpet with a goose hum, car horns, and low frequencies, then increase the volume several times. That's what Parasaurolophus sounded like. That's also what my 4th grade band sounded like. But I digress. You can listen to different shades and timbres of this dinosaur on the internet. It used noises with different tones to create complex social connections. They could communicate, identify each other, trumpet danger, or conversely, signal their friendly intentions. Alright, we've just heard how some ancient reptiles sounded. But what about ancient insects? They didn't have vocal cords, of course. Instead, they used friction between body parts. Look at modern crickets chirping with their wings. One wing has tiny notches. The second has the shape of a mediator. Take a simple plastic comb and run your fingertip over its teeth. Crickets make their sounds by the same principle. Their wings vibrate and release a series of sound waves into the air. But the clicking of an ancient bush cricket was very different from modern insects since they were much noisier. The sounds of these clicks were like a whistle. With the help of high-frequency waves, they could also communicate secretly, as if they were doing it through a closed radio channel. If you heard this, you would hardly be able to fall asleep to it. Now, modern crickets are not so loud, as they began to add more high frequencies to their sounds. Higher pitch waves don't spread as far, reducing the risk that a bat will hear the insects. Just imagine how the jungle of that time sounded. The loud chirping of crickets hurts the ears. Then you hear a brachiosaurus hissing. The clicks of pterodactyls shake the sky like thunderclaps. Then you hear the trumpet sounds of different tones somewhere in the jungle. These are Parasaurolophus communicating with each other. And then you get scared by a loud Tyrannosaurus siren. What a racket! You'd probably not find peace in such conditions. Fortunately, humans appeared millions of years later. And, by the way, scientists have managed to find out and understand what our distant ancestors sounded like. They carefully examined the insert function of the mouth, nose, and throat on the Neanderthal skeleton. Their voices were similar to ours, but the phonetic range of an adult Neanderthal was the same as if they were 2 to 3 years old. It was like mumbling without consonant sounds. The study of the skull couldn't recreate precisely the sound of Neanderthals, but in 2007, scientists extracted DNA samples from their bones. They found a variation of the gene that responds to human speech. Scientists believe that Neanderthals fought with Homo sapiens, our family tree. As a result of this conflict, their kind became extinct. But the found gene points they could have had other connections with each other. Perhaps Neanderthals could understand their language and even pronounce some words.
How heavy is the largest living snake? How can a snake eat a whale? Get ready, I'm about to answer these questions. Before the last ice age, giant mammals like mammoths ruled the world. The modern animal kingdom we're familiar with was shaped around 55 million years ago. There were still 1,000-pound bear dogs living from Asia to America. But modern whales, for instance, began to appear later. I'm saying modern whales because, surprise, surprise, whales weren't always fully aquatic. The ancestors of the ocean's biggest animals once walked on dry land. They had 4 legs and lived on the coast. Now, I want to introduce you to a snake that used to eat these whales, the Paleophis, a genus of a marine snake. Scientists say it's hard to understand how big the Paleophis was due to its fragmentary fossil record. They assumed that it could have reached up to 40 feet long. Its fossils were found in different parts of the world, from England to Morocco and Virginia, USA. The Paleophis is extinct now, and sea snakes today are only about a quarter of the size this majestic creature used to be. So no need to worry about this underwater monster. But there once was an even bigger snake, the titanoboa. It was around 50 feet long and most likely weighed over a ton. It used to live in what is now known as northeastern Colombia around 60 to 58 million years ago. Scientists say that it mostly fed on fish. Another giant animal that lived in the past was the black Gigantopithecus. These primates aren't related to gorillas. They lived in the area of modern China. Some people believe that they're still alive, but so far, no one has laid eyes on them. Some people even go further and say that the stories of Bigfoot or Yeti are based on these animals. This rodent became extinct about 2 million years ago. Its main habitat was South America, more specifically, Uruguay. What's astonishing about this species is that it was the largest rodent ever known. It was bigger than a bull. Scientists believe that it weighed up to 1,000 pounds. A distant relative of this rodent is still alive today. It's called the pacarana. It's a rare animal that lives in South America. It weighs up to 33 pounds and measures up to 31 inches, not including its cute and fluffy tail. The Arthropleura was an insect that lived in prehistoric times. Imagine a giant millipede measuring up to 8 feet in length. Here you go. It was one of the largest land animals of its era, about 315 million years ago. The Arthropleura's shell was covered with tough plates. These plates were there to protect the creature from damage. Most of the time, it burrowed into the ground to avoid becoming some other animal's dinner. Meet the megalodon. Millions of years ago, this shark lived in the ocean and ate other marine creatures. It had wide teeth, and its jaws were so powerful that the animal could finish off its prey with the force of its bite. It was one of the largest sharks to ever exist. Yet, this predator also went extinct. Scientists don't really know the reason. This made me wonder why animals were so big in the past. Nowadays, smaller creatures flee or hide from predators. But apparently, it wasn't like this before. Many centuries ago, animals didn't just run or hide, they fought back. Research suggests that this behavior may have been the most important motivation for prey to grow bigger. A study compared the skulls of ancient animals to those of their modern peers. The skulls of predatory animals have become shorter and narrower, while the skulls of the animals they hunted have become longer and broader. This means that predators learned to become experts in hunting, while prey worked on developing their defense skills. You see, a larger body size was a great advantage because it made it harder for predators to take down the animals they hunted. The bottom line, self-defense made prehistoric animals larger. The second reason why ancient animals were larger is related to their bones. They had hollow bones, which are lighter than solid bones. This type of bone allowed large animals to move quickly. Let's take sauropods. They were a dinosaur subgroup. Sauropods had giraffe-like long necks and snake-like long tails. Compared to their body size, their head was really tiny. But since their bones were quite light, they could move around without having to carry additional weight. The eating habits of these animals were also related to their body size. When experts examined the fossils of one extinct mammal species, they found out that these animals had a diet that was high in nutrients and low in fiber. And this mammal was the largest land animal of its period. In other words, following this diet, mammals could grow to be very large. There was plenty of food out there, so they didn't have to worry about finding it. Fun fact, these animals also took chewing out of the picture. They could swallow their food in large pieces instead of taking small bites. Environmental conditions also played an important role in the evolution of larger animals in prehistoric times. Those animals tended to live in warm, moist climates that provided them with a lot of food. They didn't have to compete for food sources. Researchers believe that because of these conditions, natural selection worked in a certain way. I mean, body size was more important than such traits as agility and speed. Oh, and did you know that large animals tend to produce more carbon dioxide? And ultimately, a bigger volume of carbon dioxide increases the amount of vegetation in the animal's habitat. As for the abundance of oxygen in the atmosphere at that time, it could be another vital element for some animals' growth. A good but scary example of an animal that benefited from the high levels of oxygen can be the cockroach of the Paleozoic era. At that time, cockroaches were the size of modern house cats. Now this one would give me the chills if I ever faced it. Ugh. What about today? Well, there are over 3,000 species of snakes on Earth. The smallest snake in the world is the Barbados thread snake. It's only around 4 inches long when fully grown, and the largest one? It's the reticulated python. This snake reaches around 20 feet in length. The longest python was discovered in 1912. It measured 32 feet long. As for the largest and heaviest reticulated python, it was named Medusa. Medusa was approximately 25 feet long and weighed 350 pounds. These reptiles lived in Southeast Asia in rainforests, woodlands, and grasslands. Don't be confused though, the reticulated python isn't the heaviest snake in the world. This title belongs to the green anaconda. It weighs approximately 500 pounds. Green anacondas are found in South America and Trinidad in damp, humid areas. I have a bonus for you. Here is a flying snake. You can find these snakes in Southeast Asia. They don't fly like birds, of course, but they do use the power of flight. They can go as high as 300 feet. They leap from tree branches into the air. Once they take off, it's all about aerodynamics. Their main technique is flaring their ribs and pulling in their abdomens. While airborne, they undulate from one side to another and slightly up and down. This motion helps snakes to turn and glide. Why bother with all this if they can just crawl in an old-school way? Scientists aren't sure, but they believe it might be related to escaping from predators. This way, they move from one tree to another without having to get down to the ground. Every now and then, people discover fossils of animals that lived millions of years ago. These ancient discoveries continue to capture our imagination. Which of these animals would you like to see alive?
So, a mysterious discovery was made deep in the Red Sea, the so-called death pools. Woo, that's scary. In 2020, researchers embarked on a dive into the Red Sea. The mission spot was in the Gulf of Aqaba, between Saudi Arabia and Egypt. Near the end of their expedition, as they ventured deeper into the darkening waters, they noticed some strange seaweed floating above the seafloor. They decided to use a remotely operated vehicle and investigate it. Suddenly, they discovered these strange, motionless lakes of water within the sea. These are called brine pools. They're basically pockets of salty water deep on the ocean floor. And when I say salty, I mean it. Sometimes they're up to 8 times saltier than the ocean water itself. Mysteriously, they don't mix well with the surroundings. They formed millions of years ago, sometime during the Miocene epoch, back when weird creatures roamed the earth, like me, and deeply buried mineral deposits dissolved into the water. The largest pool spans about 170,000 square feet. Meanwhile, 3 smaller ones are under 107 square feet each. At first, this discovery didn't seem that scary. But here's why they're so horrifying. Not only are they disgustingly salty, they also lack oxygen. Now hold on a sec, isn't that normal for something that's underwater? Well, it turns out the Earth's waters are full of oxygen, and at least half of this element on our planet comes from the oceans. Just like plants on land, marine plants such as phytoplankton, seaweed, and algae munch on sunlight and produce oxygen through photosynthesis. They release lots of it into the surroundings. Marine life then eats half of it, so only about a quarter of the oxygen that we breathe actually comes from the oceans. Just like us, sea creatures need this element to survive. Without it, they can't breathe and support their metabolism to live. That's why these pools are super dangerous for most of them. It's like a puddle of thick syrup for bugs. When they get in, the poor things immediately suffocate and pass away. Which is why the pools are surrounded by a graveyard of marine animals. But let's see how these things can exist in the first place. Have you ever tried making ice cubes from salty water? Spoiler, it's pretty hard. When you add salt, the water gets harder than usual to freeze, a phenomenon that has a funny name, freezing point depression. Oh, that's because salt interferes with the hydrogen bonds between water molecules. As it finally freezes, stuff like particles, dirt, or dissolved salts get pushed out to the sides. As a result, the salt's kind of squeezed out of the ice crystals and gets trapped near the edges in small bubbles or pockets. Something similar happens in the ocean when seawater starts freezing under super cold polar caps. The salt doesn't freeze with the water. Instead, it gets pushed out, forming a super salty cold liquid, the brine. And then it sinks down to the ocean floor. On a large scale, all this process also helps currents to form. Despite being so dangerous, the pools are still full of microbial life, because microbes couldn't care less, they'll survive anywhere. There are literally thick mats of them in the brines. There are also some salt-loving creatures, like shrimps and eels, hovering around the pool's edges. They're being super creepy, waiting to catch unsuspecting prey that ventures too close to the toxic death pool. Ew. Well, it sounds icky, I know. But this discovery gives us some fascinating insights into how life might have originated on Earth. We already know from the evolution theory that we came from the ocean, but now scientists think that life might have begun in the deep sea in some super dark, oxygen-free places. These brine pools are like time capsules. They're one of the closest things we found to the early Earth. They can tell us the planet's history of earthquakes, floods, tsunamis, and more. For example, they have some traces of rainfall that happened over 1,000 years ago. And they can also help us search for life on other water-rich planets. For example, Mars most likely used to have huge oceans on it. Now, NASA scientists want to send a special instrument called HABIT for a special red planet mission to study things similar to our brine pools. This will tell us more about how life appears and survives in the universe. There is lots of unexplored fascinating stuff like this in the Red Sea. That's why scientists conducted the so-called Decade Expedition and spent around 5 months exploring the place. This expedition was launched by the National Center for Wildlife. They made so many remarkable discoveries that now we've got 77 new research papers. For example, they found over 10 blue holes, incredible underwater sinkholes that host unique ecosystems. They also learned that dolphins can use those blue holes to protect their young from predators. Scientists also found traces of great white sharks, a creepy community of deep-sea lanternfish living in low oxygen conditions, and even a new coral species. It's the most resilient deep-sea corals that also vibe just fine without oxygen, like microbes we mentioned. Speaking of which, research also showed us some new ancient thermal vents and large blobs of microbial formations near Farasand Island. Now, can you believe that with all that, we only explored 5% of the ocean? It's divided into several layers based on depth. Each layer becomes darker and more isolated from sunlight as we go deeper. The places that no sunlight can reach are terrifying. Now, the fun, cute layer with dolphins and turtles is called the epipelagic or sunlight zone. It's so tiny, but even this layer is about 650 feet deep. Then we have the mesopelagic or twilight zone. It's the layer of mysterious octopus, shark, and other loners which extend to about 3,000 feet down. And then the horrors begin after this one. We encounter the bathypelagic or midnight zone. It extends to 13,000 feet below the surface, about a half of Everest above you. Here we have the famous poor blobfish, squids, and anglerfish. Below it is the abyssal zone. It extends to about 20,000 feet deep. Since there's not much sunlight or oxygen, as we mentioned, most creatures here are quite small, like tube worms and shrimp. The darkness continues until we arrive at the scariest place of the planet, the place full of trenches formed by tectonic plate movements, the Hadal Zone. It's named after Hades, the deity of the underworld in Greek mythology. Just like Hades' realm is dark, remote, and guarded, the Hadal Zone is the deepest and most depressing part of the ocean. It starts at depths of around 20,000 feet and can go down to 36,000 feet and more. The famous Mariana Trench also belongs to this zone. Only 3 people in history have ever explored these depths in person, making it one of the least explored and most mysterious places on our planet. However, despite crazy high pressure, near freezing temperatures, and complete darkness, there are still things who manage to survive here. Guys like amphipods, which are critters who feed on dead material sinking from above, and the Hadal snailfish, which lives as deep as 27,000 feet. So scientists used to assume that if there's no sunlight, there wouldn't be that much oxygen around. But one day, a research team decided to measure the levels of oxygen in one of those deep zones. Surprisingly, the levels were super high. They checked the equipment thinking that it was malfunctioning, but nope, all the sensors showed the same thing. Turns out the oxygen was somehow generated by rocks. These small potato-sized rocks on the seafloor are called polymetallic nodules. They're rich in metals like copper, nickel, and cobalt, and they're basically like small batteries. When you put a battery in salt water, it can produce bubbles of gas, a process called electrolysis. In the same way, these rocks create tiny electric currents, which are powerful enough to produce the same gases, splitting water molecules into hydrogen and oxygen. It's the first time we saw oxygen being produced by some non-living minerals. This is what scientists now call dark oxygen. It turned out that about half of large marine species, or megafauna, were living just on dark oxygen alone. All these discoveries are reshaping our understanding of where and how life could evolve. It means that we might be able to find life on other planets or satellites with low oxygen conditions, like Enceladus and Europa, the moons of Jupiter and Saturn, and they have large bodies of frozen water on them. Wow!
Not much happens in dark, murky ocean depths. It's mostly pretty quiet, with some smaller fish carefully passing by and probably hoping nothing big would grab them on their way. There's also a bigger fella looking for plankton coming through every now and then. Suddenly, a giant beast comes out of nowhere. First, it's just a dark dot in the distance, until it gets closer. Oh, it's a great white shark. You can recognize its firm dark gray body, white belly, and slanted head. These creatures have special cells in their skin called melanocytes that can make their color change to lighter or darker. This way, a shark can blend in with its surroundings, which is a nice ace up its sleeve and the reason why we barely even see one coming by. These predators can grow up to be more than 20 feet and weigh up to 5,000 pounds. Our fierce fella is just passing by looking for some lost fish that might wander around, if it gets lucky, directly into its mouth. But instead, a giant jagged tentacle comes out of nowhere. The great white barely escaped it and quickly swam a little further to see what was happening. A giant squid comes out of the depths. Its eyes, as large as dinner plates, are looking straight at the shark, while its soft body is getting closer. A challenging prey, but hey, why not try? Most of the time, these creatures eat shrimp, fish, and other squid, but sometimes they like to really treat themselves, so they go after small whales. A shark will do too. I know you'd expect these creatures to be way smaller, or that's at least how I comfort myself when I swim a little further from the shore where my feet can't touch the bottom anymore. But they can weigh 600 pounds and be 40 feet long. The great white shark is the biggest predatory shark on our planet. Check out its long and sharp teeth. It definitely has the biggest smile down there in the ocean. Great whites have around 300 teeth, but they don't use most of them for biting. Instead, they have a special system where new teeth grow all the time because they need to replace the ones that get worn out or lost. And they have a really powerful bite, over 20 times stronger than ours. Considering all that, you might think a great white shark has nothing to be afraid of in the ocean. But looking at its gigantic enemy, we can't be so sure of that anymore. Octopuses only have 8 arms. Squids too, but they also have 2 additional tentacles. They're similar to their arms, but suckers on the arms go along most of their length, while tentacles have suckers only at the ends. This squid has probably hundreds or even thousands of suckers. There are squids without these suction cups, but in that case, they have rotating hooks, or a combination where these two work together. Hooks catch prey, and suckers stick on it so it doesn't get away. Squids have teeth too. Plus they have this special part called a radula. It's like a tongue, but with teeth on it. The teeth are tightly packed together and are difficult to remove. When food is passed to the radula, the teeth chew it into small pieces. This is important because squids have sensitive body parts near their throat, so they need pieces of their food to be very small. Their bite may not be as strong as the great white sharks, but it's still quite powerful. For instance, way stronger than a lion's. They also have glands that produce venom and use their beaks and radula to inject the venom into their prey or a creature that's coming after them. Wow, these squids are really equipped better than expected. And they're also way longer than the great white, which gives the squid more room to attack it with its long tentacles from a distance and seize it. Giant squids usually live at depths of 2,950 feet, while great whites prefer to stay at depths of about 650 feet. But we'll try to keep the competition fair. Let's say these two meet in a territory where water pressure won't hurt or bother any of these animals. The great white is circling around the squid. It moves a bit faster than the squid. Its swimming speed can reach 25 miles per hour when the animal is submerged, and it also has short bursts of speed when it can move at 35 miles per hour. Giant squids move at around 25 miles per hour. Just for comparison, an average human swims at 2 miles per hour. But with its length, the giant squid has more room to attack the great white shark with its long tentacles from a distance. They can stretch for 33 feet to snatch the prey. And look, it's really trying. But it ain't that easy. Not only is the great white big and fast, but it also has special sensors called the ampullae of Lorenzini. It's a good tool to detect prey and generally stay safe in the ocean. But the squid is definitely no joke. It has activated its special defense mechanism and released thick black ink. The great white is confused. The ink is like a smoke screen, which gives the squid enough time to get away. The shark can't see its opponent anymore. The squid is getting closer, and the poor great white has no idea from which direction. It's time for the final move. Even if the great white manages to catch the squid can detach parts of its body as a last resort to protect itself. It can lose up to 10 body parts, unlike sharks. These predators can't lose any essential body parts because they won't survive. And look, the squid finally latches onto the shark. Its suction cups and the sharp beak that can pierce its prey make it nearly impossible for the shark to escape. They both disappear into a cloud of ink, the great white shark in one of the rare fights it can lose, and the giant squid ready for new conquests across the ocean. Aren't giant squids perfect for scary stories? In legends, there are often battles between humans and sea monsters. In the past, Norwegian sailors shared stories about sea creatures they encountered during their ocean travels. Over time, these stories grew to include creatures that were like giant islands with arms. And let's not forget about the Kraken. It's a legendary sea monster from Scandinavian stories that looked like an island, which was how it would trick sailors. The spooky stories say the beast was using its long tentacles to grab ships and drag them to their doom. And do you remember Jules Verne's novel 20,000 Leagues Under the Sea, which describes an encounter between a ship and a giant squid? In real life, giant squids don't eat humans, and they're not particularly interested in going after ships. However, not all the stories about these creatures attacking ships are made up. There are some reports. For example, in the 1930s, something attacked a Norwegian tanker, the Brunswick, 3 times. And yes, it was indeed the work of a giant squid. Fortunately, the squid couldn't grip onto the ship's steel hull, so it ended up getting caught in the propellers. But even though everything was okay in the end, just looking at this gigantic monster trying to take your ship down to the bottom must have been terrifying. We can laugh at stories about the Kraken until we're out there on our own. In 2003, a giant squid came closer to a French yacht that was participating in a sailing race. It couldn't cause any harm, so it eventually gave up. So, for now, the idea of a giant squid taking down a ship or boat remains a fictional story, although they're certainly capable of trying. Okay, giant squids are big, but there's another creature from their family of cephalopods that can be even larger. It's called the colossal squid, and one that was found weighed 992 pounds, hundreds of pounds more than the giant squid, 606 pounds. And they can stretch their tentacles for up to 45 feet.